Today we'll be learning about how to calculate the area of a circle. Area, if you remember, is the amount of space that is inside of our circle. And to help us find the area of a circle, we're going to try to develop a formula. Now, you learned yesterday that there are two formulas for circumference, and that's going to play into what we're doing here right now with our circle. Notice I've got 8 sections there. What I'm going to do with my 8 sections, I'm going to try to stack them to form sort of like a parallelogram or a rectangular shape. And so I'm just going to go ahead and I'm going to sketch what this might look like. So you can imagine that that's one of my little sections from the circle right there. And then I'm going to take the second section and I'm going to attach it on the bottom like this. Okay. And then I'm going to continue doing this until I've used all 8 sections of the circle. And so there could be our third, and our fourth, and our fifth, our sixth, our seventh, and our 8th section of the circle. Okay. And as I mentioned before, we were trying to create something that looks like a rectangular or parallelogram, and it's not perfect, but it closely resembles what a parallelogram would look like. And you'll notice in the box right here, we've got the area formula for a parallelogram, which says that area equals base times height. Well, in order to help us come up with the area of the circle, we need to think about what these parts, the base and the height, are from our original circle. If you notice the base, this section down here, well, this is the curved section of our circle. And if you remember from yesterday, that distance around the circle was our circumference. So our base, going from here to here, well, it's not the entire circumference, because you'll notice up here at the top that we also have the curved part from our circle. And so actually, if you look at this distance from here to here, this is going to be 1/2 of the circumference. All right, that distance from there to there. Next thing we need to do is try to figure out, well, what does the height of our parallelogram represent from our original circle? And if we look at what this distance would be, all right, from this point here to this point that lands on that curved section, well, that is going to end up being the radius of our circle. And let me get my pencil working again. There we go. Okay, and so we can see here that we have a base that's half the circumference and a height that's represented by the radius. And so if we look at this formula, if we plug in our new terms here, the area is going to equal, instead of the base, well, that's half of the circumference, times the height, which was going to be the radius of our circle. Okay, and now what we're going to do another substitution. Rather than keeping this in terms of the circumference, we learned yesterday that the circumference could either be pi times the diameter or 2 pi times the radius. And since we're using the radius here, that's what we're going to do. We're going to substitute in the circumference formula using the radius. So we're going to keep our 1/2 times the circumference is the same as 2 pi r times the radius. All right, and so our formula is starting to take shape. And now what we can do with this is do some simplification. Half of 2, well, that's just equal to 1. So the area is equal to 1 times pi times the radius again. And since I've got the radius multiplying itself here, I can use an exponent to represent that. And so area is going to equal pi times, well, r times r is r to the second power. And this formula right here is the formula that we're going to use for the area of a circle. Area equals pi r squared. Okay, now there's one formula for the area. You learned yesterday that there are 2 for the circumference. Also remembering what we talked about yesterday, remember the different parts that make up our circle. If we look down here at our circle, remember, this segment that goes through the center and both of its endpoints are on the circle, this is your diameter. And then this segment that starts on the circle and goes to the center, this is your radius. The radius, if you remember, is half of the diameter. A diameter is equal to 2 times the radius. Okay, and so underneath we've got some practice problems where we're going to find the area and the circumference of our circle. Okay, and the first thing that we're always going to do is make sure that we write down our formula. Let's start with the area. We just came up with the area formula. Area equals pi r squared, pi times the radius squared. And looking at our picture here, we can see, well, this segment is the radius. It's equal to 3 meters. And so we're going to substitute that value right in for the radius. Area equals pi times 3 to the second power. Now, we have to remember our order of operations when we're trying to evaluate this area. We are going to have to do the exponent before we do the multiplication. When we do this, 3 to the second power, 3 squared is equal to 9. And so the area is equal to 9 pi. Now, if we wanted the area in terms of pi, we'd be all set. That would be all that we need to do. But what we're going to go ahead and do, because down here it says we're going to round our answer to the hundredths place, I'm actually going to use my calculator and I'm going to figure out what 9 times pi is. So area equals, and now let's pull out the calculator here. I'm going to hit 9 times, and then there's our pi key right here. I'm just going to hit that, hit equals, and on your paper, you're going to write out this entire decimal. Write out all of the digits that you see on your calculator. So we're going to have 28 and 2743388. And now we're ready to round our answer to the hundredths place. And so looking at my number right now, it looks like I have 27 hundredths. I checked the 4 in the thousandths place. That's not enough to round us up. And so we're going to say here that the area is approximately, not equals, but approximately 28 and 27 hundredths. And now we need our units. Well, you see right here in our circle that we had meters, but with area, the units always get squared. And so it's going to be 28 and 27 hundredths meters squared, or square meters for the area. Okay, now we're ready to move on and calculate our circumference. Remember, there were two formulas for circumference, one that uses the radius, one that uses the diameter. Since we have the radius in our circle, let's use the circumference formula that uses radius. C equals 2 pi r. And now we're ready to do just like we did with the area. We're going to substitute in the value of the radius first. C equals 2 pi times 3. Okay. And now I'm ready to do all of that multiplication. So I'm going to do 2 times 3, which I know is 6, and then 6 times pi on my calculator. 6 times pi. And again, I'm going to write out all of these numbers. 18 and 8495592. And then just like I did with the area, I'm going to round this one to the hundredths place. So I'm going to say that the circumference is approximately, and it looks like 84 hundredths. That 9 in the thousandths place, though, is going to round us up. And so we're going to have 18 and 85 hundredths. And the units here, again, are just meters. We do not square with circumference. You only square the units when you're working with area. Okay, I'm going to have you go ahead and practice that down here with this second circle. Notice this time, though, that we've got the diameter. The area formula, though, if you remember, area equals pi r, or radius, squared. So think about what you're going to have to do to this in order to come up with that radius. For my circumference, well, I know the diameter. I'm going to use the circumference formula that uses diameter. C equals pi times the diameter. All right, one item that we haven't talked about are semicircles, and by looking at the pictures, I'm sure that you can guess that a semicircle is just a half a circle. And so in question number 3, they want us to find the area of this semicircle. Well, using the formula that we had before, we know that to find the area of a full circle, we would have to do pi r squared. However, we're not working with a full circle anymore. We have a semicircle, which is just a half a circle. And so that's what I'm going to do. I'm going to put a 1/2 in front of my pi r squared. And this is the formula that we're going to use. Area equals 1/2 of pi r squared. Okay, and so now we're ready to do a substitution. And I need to know the value of the radius. Well, looking at this length here, if I imagine if this was a full circle, 16 inches would end up being the diameter. But I need the radius. Radius is half the diameter, so I'm going to do 16 divided by 2, which is going to give me 8 for my radius. Following order of operations, now we're ready to do the exponent. We still have our 1/2 pi. 8 to the second power, 8 times 8 is 64. And then I just want to make this a little easier on myself. I know that half of 64 is 32. A equals 32 pi. And again, if I wanted to leave my answer in terms of pi, I would be all set. But for the fun of it, we're going to go ahead and practice multiplying by pi with our calculator. So again, we're ready to pull that out, 32 times pi. And we're going to write out all of those numbers, 105,309,649. Now the directions here don't ask me to do any rounding, so I'm not going to round, and I'm just going to keep this, and I'm going to put my units now of inches squared. They're square inches. Remember, area, you square the units. In question number 4, you're going to find the distance around this semicircle. Distance around is our circumference. And again, this 100 from here to here would be the diameter if we had a full circle. So we're going to use the circumference formula that uses diameter. C equals pi d. But again, it's not a full circle. It's just a half of a circle. So we're going to put a 1/2 in front of it. But we're not done yet. This is just going to give us the curved part of the semicircle. We still have to take into account that we need to add in this extra piece right here, which again is our diameter. So we're going to add in the length of the diameter again. 1/2 pi d gives us the curved part plus this diameter right here. And now we're ready to go ahead and do our substitutions. C equals 1/2 pi times 100 plus 100. Remember your order of operations. We've got all this multiplication to do before we do our addition. C is going to equal, well, half of 100 is 50 times pi plus 100. And now I'm going to do my multiplication, 50 times pi. So let me punch that in, 50 times pi. And I'm writing out all of those numbers, 157 and 07,96327. Don't forget, plus 100. And so that addition now is the last part of our problem here. When we add 100 to this long number, we're just going to get 257 and 07,96327. And again, we're going to keep our units. In this case, looking up here, they were going to be centimeters. And so these are the formulas. Here's the area formula and your circumference formula for a semicircle. Okay. Underneath, you have 2 more practice problems. They're word problems. And you're going to be finding the area in each case there. I'm encouraging you to draw a picture for each of those examples to help you determine the formula that you're going to need. In number 5, it says the radius of a circular coin is 1.5 centimeters. So I'm just going to go ahead and draw myself a circle, and I'm going to give it a radius of 1.5 centimeters. Okay. And again, I know my formula for area. Area equals pi r squared. For question number 6, it says to find the area of a pool cover to a circular swimming pool whose diameter is 20 meters. So this time I'm going to draw a circle, and it's going to have a diameter of 20 meters. But remember our formula, area equals pi r squared. Again, we're finding the area here, so we need to know the radius. If the diameter is 20, well, to get the radius, we have to take the diameter and divide it by 2. So in this case, 20 divided by 2 is going to give us 10. And I'm going to leave the rest of the substitutions and all the work up to you.